Imagine this: deep beneath the freezing ocean, a submarine is detected by enemy sonar. Seconds later, a torpedo is launched fast, intelligent, and designed for one purpose only: to hunt and destroy whatever it locks onto. The crew inside the submarine has no room for mistakes. Normally, this is the moment when escape becomes almost impossible. Torpedoes are faster, relentless, and unforgiving. But in this case, something unthinkable happens. The submarine doesn't hide. It doesn't deploy decoys. It doesn't dive deeper or turn sharply. Instead, it accelerates. The distance between the submarine and the torpedo begins to grow. Alarms scream, sonar operators panic, and naval commanders on the surface struggle to believe what their instruments are showing. A submarine, an underwater machine weighing thousands of tons, is actually outrunning a weapon specifically designed to kill it. For decades, this idea belonged to science fiction, yet during the Cold War, it became terrifyingly real. To understand how this was even possible, we need to go back to a time when the world's oceans had turned into silent battlefields. The Cold War wasn't only fought with nuclear missiles and spies, it was fought underwater, where submarines carried weapons capable of ending civilization itself. In this hidden war, speed was considered almost useless. Stealth was everything. The quietest submarine survived, and the fastest torpedo always won. Or at least, that's what every naval doctrine believed. But one nation decided to challenge this rule completely. Engineers were given an almost impossible task: build a submarine so fast that it could escape its own execution. What followed was a radical experiment in engineering, nuclear power, and human risk, an experiment that shocked NATO, rewrote naval strategy, and produced one of the most dangerous submarines ever built. This is the true story of the insane submarine that outran torpedoes. For most of modern naval history, torpedoes were considered the ultimate underwater predators. Once launched, they would lock onto their target using sound, pressure, or wake detection, and from that moment on, escape was unlikely. Submarines were never designed to outrun torpedoes. Instead, survival depended on silence. Crews trained endlessly to reduce noise, slow down, and disappear into the ocean's background. A loud submarine was a dead submarine. Torpedoes, on the other hand, were built for speed and aggression. By the Cold War era, many torpedoes could travel faster than 45 knots, far beyond what most submarines could ever reach. Naval doctrine across the world agreed on one rule: if a torpedo is fired and tracks you successfully, speed will not save you. This belief shaped submarine design for decades. Engineers focused on quiet propellers, vibration isolation, and stealth coatings, not raw power. The idea of outrunning a torpedo was considered absurd, almost childish. The ocean is dense, drag is enormous, and submarines are massive steel structures. Speed came with noise, and noise meant death. This was the balance of underwater warfare. But during the Cold War, as technology advanced and tensions grew, some military planners began to wonder if this rule could be broken. What if, instead of hiding from torpedoes, a submarine could simply escape them? What if speed itself became a weapon? These questions would lead to one of the most extreme engineering experiments ever attempted beneath the sea. By the 1960s and 72nd, the Cold War had transformed the world's oceans into strategic chessboards. The United States and NATO relied heavily on stealthy nuclear submarines capable of tracking Soviet vessels and launching devastating strikes if war ever broke out. These submarines were quiet, patient, and deadly. To Soviet naval commanders, this posed a terrifying problem. Their own submarines were louder, easier to detect, and more vulnerable to advanced Western torpedoes. Each NATO improvement widened the gap. Soviet leadership feared losing control of the underwater battlefield entirely. In response, Soviet engineers were encouraged to think differently, sometimes recklessly. Instead of trying to match Western stealth, some designers proposed a radical alternative: abandon silence and embrace speed. The logic was simple but dangerous. A submarine that could move faster than any torpedo would never need to hide. It could strike quickly, escape instantly, and leave enemies confused and helpless. This idea shocked traditional naval thinkers. Speed required immense power, and immense power created noise. Noise attracted torpedoes, but the Soviets were willing to accept risk in exchange for shock value. They wanted a submarine that would terrify NATO not because it was invisible, but because it was unstoppable. This philosophy would give birth to a project that pushed metallurgy, nuclear engineering, and human endurance to their limits. The result would not just challenge Western assumptions, it would rewrite them. The submarine that emerged from this radical thinking was known in the West as the Alpha class. From the very beginning, it was unlike anything the world had seen. Its most revolutionary feature was its hull, made almost entirely from titanium. Titanium was lighter than steel, stronger under pressure, and resistant to corrosion, but it was incredibly expensive and extremely difficult to work with. Welding titanium required specialized facilities and precise conditions, pushing Soviet industry to its limits. But the benefits were enormous. The lighter hull allowed the submarine to dive deeper and move faster with less resistance. Inside, the Alpha class used an experimental liquid metal-cooled nuclear reactor. Unlike traditional reactors, this system delivered massive power almost instantly, allowing the submarine to accelerate at shocking speeds. It could go from slow movement to full speed in moments, a nightmare scenario for enemy forces. Automation replaced manpower wherever possible, reducing the crew size dramatically. This wasn't just about efficiency, it was about survival. Fewer people meant less life support demand and more space for machinery. However, this also meant extreme pressure on the crew. Every system was complex, unforgiving, and dangerous. A single mistake could be fatal. The Alpha class was not designed for comfort or long patrols. It was a weapon built for short, intense missions, fast, aggressive, and terrifying. When the Alpha class finally entered service, it stunned Western navies. NATO sonar operators began reporting contacts that made no sense. Submarines were detected moving at speeds previously thought impossible. In some encounters, Soviet submarines appeared to chase NATO vessels instead of avoiding them. The Alpha class could reportedly exceed 40 knots underwater, and some estimates placed its top speed even higher. More shocking was its acceleration. Torpedoes rely on prediction, calculating where a target will be in the future, but the Alpha class could change speed and direction so rapidly that those calculations became unreliable. In certain scenarios, especially early in a pursuit, the submarine could increase distance faster than some torpedoes could close it. This did not mean it was invincible, but it broke psychological barriers. Western commanders suddenly had to imagine the unthinkable. A submarine that didn't fear torpedoes. The ocean, once a realm of slow and silent hunters, now had a sprinter. NATO was forced to rethink torpedo speed, guidance systems, and engagement tactics. Faster torpedoes were developed. New doctrines were written. Even when the Alpha class wasn't present, its shadow loomed large. It proved that the rules of underwater warfare were not fixed, and that speed, when pushed to extremes, could be just as disruptive as stealth.